Okay, good morning, afternoon, night, trigonometry students. We're going to pick up where we left off the last time and discuss radian measures. Radian measure is another measurement system for angles instead of degree measurements. And we say that 1 radian is the angle measure that cuts off an arc length equal to the radius. So in this pink circle, if the radius is r, how far do you have to move in order for this distance here to equal r? Generally, if you ask someone define radian measures, what they're going to say, the fact that helps them work with it so much is that pi radians is equal to 180 degrees. That's the key little fact that you need to know. Pi radians is 180 degrees. You remember that unit circle we were filling out the other day? There were some blank lines on it. And we can now start filling those in. These are the radian measures. Knowing that 180 degrees is pi radians. Now there's not really a symbol for radians. We have a little circle for degrees, but there's not a symbol for radians. So if we know that 180 degrees is pi, well, 0 degrees is sure 0 radians. I'm thinking like this. Pi is 180. So 90 degrees would be 180 divided by 2. So 90 degrees would be pi over 2. What do you multiply 90 by to get 270? 3 times 90 is 270. So 3 pi over 2. Now I'm filling these things in. These are going to be the radian measures. Now, let's do 30 degrees. 180 divided by what would give me 30 degrees? 6 is 180 divided by 6, 30 degrees. Notice I'm thinking of pi is 180. Now let's go to the other ones that have that 30 degrees as the reference angle. I'm looking at all of the ones that are closest to the x-axis. 30 degrees, 150 degrees is 5 times 30. So it's 5 times this. 5 pi over 6. What do you multiply 30 degrees by to get 210? 30 times 7, so 7 pi over 6. What do you multiply 30 degrees by to get 330? Well, 11 times 330 would be, 11 times 30 would be 330. So 11 times pi over 6. Oh, I just saw a spot I had it filled out. I should have already filled out. 360 degrees would be 2 times 180. Now let's do the 60 degree ones while we're thinking about those. And 60, I'm using the purple. 60 degrees. If 180 degrees is pi, 60 would be 180 divided by 3. Y'all getting the hang of this? 120 would be 2 times 60. 240 would be what number times 60? Well, a 4. 4 pi over 3. 300 is 5 times 60. All that's left now are the 5 degree ones. Well, 180, oops, wrong color, I was using blue here. 180 divided by 4 would give you 45 degrees. 45 times 3 is 135. Let's see. How many times does 45 divide into 225? Is that 7? No, 5. 5 pi. 5 times 45 is 225. 7 times 45 is 315. We labeled this unit circle the points of intersection the last time. Now we've finished it up. The natural question to ask is, could y'all state a rule? The main way to label these points here is do what I was saying. Think of 180 degrees as pi, 90 degrees, 180 over 2, and so forth. Well, in general, if you want to convert between degrees and radians, you're going to multiply by 1. You're going to multiply by the fraction pi over 180 degrees. Since those pi equals 180 degrees, you're multiplying by 1, which really wouldn't change it. Or you might multiply by 180 degrees over pi, depending on what you're trying to find. Here's an example. Let's convert, well, first one on here is 270 degrees. Well, that's on the unit circle, so the best way to do it is think of 3 times 90, but let's do this little multiplying. That's what I want to illustrate here. To convert from degrees to radians. With radians, there's no degree symbol. So here's how I think. Which one am I going to multiply by? Where do I put the pi? Do I put it on the top and the 180 degrees on the bottom? Or do I put the 180 degrees on top and the pi on the bottom? Well, I'm going to put the 180 degrees on the bottom because these degree marks should cross cancel. So we would have 270 pi over 180. Divide each of these by 90 to get 3 pi over 2. What about, let's see this one here, 1440 degrees. Let's type that, or let's convert that to radians. We've got 1440 degrees. Now, I'm going to put a pi in one place and 180 degrees on the other. The 180 degrees is going to have to go on the bottom, so it'll cross-cancel this little degree mark. So now, how can I reduce 1440 divided by 180? Oh, well, 1440 divided by 180 is just 8. So 8 pi. To convert 11 pi over 6 and negative 37 pi over 20 to degrees, you're going to multiply, and here you want the degree symbol up on top. So you're going to put 180 over pi. Now you can cancel the pi symbols. Let's see, we can do a little more cross-canceling, can't we? The 6 goes into 180 30 times. 30 times 11, that's 330 degrees. Ooh-wee, what about negative 37 pi over 20? How would I convert this to degrees? Well, I now want a degree symbol on top. So that's how I remember where I put the 180. Some people just memorize, okay, to go from degrees to radians, pi over 180. to go from radians to degrees, 180 over pi. But then they wind up forgetting, well, which one do we use? So you look at what you want. You want the degree symbol up on top, so it should be here. Over here, you don't want a degree symbol, so you need to put a degree symbol in the bottom to cross-cancel with that little degree symbol. So let's see, 20 goes into 189 times. I can also cross-cancel the pi's. And let's see, what's 9 times a negative 37? That would be a negative 333 degrees. Number 6. This one's going to be a calculator problem. Convert 73.56 degrees to radians. So 73.56 degrees. I'm going to radians. Here's how I'm thinking. So I don't want a degree mark in my answer, do I? That means I need to put the 180 degrees down here so it cross-cancels. And this one you're going to just punch into your calculator using your pi key and round to the nearest thousandth. Let me see if I can get this to show up here. What I'm going to do. Oops, clear out that. I'm going to go 73.56 times second pi divided by 180. 1.283. How were we told to round that? To the nearest thousandth. So 1.28386 tenths, hundredths, thousandth. Do I leave it as a 3 or make it into a 4? 4? So this is converting between degrees and radians. Got to keep straight. When do you multiply by pi over 180 degrees, and when do you multiply by 180 degrees over pi? Let me see. Let's see. Then it reverts just to pretty much the rest of these unit circle problems. Sine 7 pi over 6. That's why it's important that you be able to label this unit circle. 7 pi over 6 is right here at 210 degrees. Sine's the y-coordinate. So sine 7 pi over 6, negative 1/2. What about tangent pi over 3? Pi over 3 is right here. Sine over cosine. Sine over cosine. That's going to simplify down to what? Just square root of 3. Look at all those 6 choices. That makes it harder just to guess, doesn't it? And the rest, it's very much like number 11. Okay, there's all these words and stuff, but it's telling you to find secant 7 pi over 3. Well, 7 pi over 3 isn't one of the angles on here, is it? It's bigger than 2 pi. 6 pi over 3 would be 2 pi. So just like what we did with degree measurements, we would subtract 360 until we got an angle that was between 0 and 360 degrees. I'm just going to subtract 2 pi, thinking of 2 pi as 6 pi over 3. Pi over 3. Sometimes students will say, well, wait, couldn't I just do this as degrees? And that's right. Pi over 3 would be 60 times 7, so if you want to do it as degrees, that would be 420 degrees. So Either way, you're looking right here at 60 degrees. So secant is the reciprocal of cosine. So the reciprocal of 1/2 is 2. Here are a couple of problems I wanted to do. Number 12. You're finding the angle value, which they're calling S. Find the exact value of S in the given interval. It says don't use a calculator. Again, you've got to, even though if you want to use, try. This is especially true for the online students. Don't rely on that calculator too much. You've got to know this unit circle. It would be a shame if towards the end of the semester you have to spend your time memorizing this unit circle because you didn't memorize it now. Under document sharing, I have this blank unit circle, so you could print it out and practice filling it out as many times as it takes till you have this thing memorized. Okay? So number 12 says, look in the interval from pi to 3 pi over 2. Well, that would be from pi to 3 pi over 2. That would be this third quadrant. Tangent S is square root of 3 over 3. You're trying to find S. So at which of these angles, if you go sine over cosine, sine over cosine, sine over cosine, where would you get square root of 3 over 3? Well, it would be here at 7 pi over 6. If you went sine over cosine, that would be negative 1/2 over negative square root of 3 over 2. Have y'all got the hang of reducing this? Multiply above and below by 2 to get 1 over the square root of 3. And then you would rationalize, right? To get square root of 3 over 3. So your answer here is 7 pi over 6. Here you're sort of going in reverse. That's how you do everything in math. You do it one way, then you do it the other way, in reverse. You FOIL and then you factor in algebra. So here we were told that the tangent was square root of 3 over 3, and we had to figure out the angle value. And the angle is 7 pi over 6. What about number 13? Well, we're told look from 3 pi over 2 to 2 pi. That would be from 270 to 360 degrees. Where is the tangent equal to negative 1? So if you go through sine over cosine, sine over cosine, sine over cosine, where would that give me negative 1? Sine over cosine, that'd be 7 pi over 4. Okay. Any questions there? Is there anything else? Oh, there's still one more like this. Here we're told, look from 0 to pi over 2. So that would be in quadrant 1, 0 to pi over 2. Where's cosine square root of 2 over 2? Cosine would be square root of 2 over 2 at pi over 4. And it might look like I'm just writing the answer out. Well, yeah, that's what I'm doing. Okay? It takes a little thought. And the rest of these are just let's see, do we have time to do one more? Look, there's negative 7 pi over 4. You know what? I'm going to do this the lazy man's way. I'm going to convert this to degrees. And then what do? Just add 360 degrees until you get until you get an angle between 0 and 360. Or if you want to do it with radians, just add 2 pi. Hey, maybe I'll do that. Just add 2 pi. That 2 pi over 1, we would need a common denominator. So write that as 8 pi over 4. So would that just be pi over 4? So sine negative 7 pi over 4. Negative 7 pi over 4 is coterminal with pi over 4. So what's a sine of pi over 4? Well, maybe I'll have got the hang of that. Pi over 4, they're both square root of 2 over 2. So sine is square root of 2 over 2. Cosine square root of 2 over 2. Tangent, sine over cosine, that's going to be a 1. Reciprocal of sine, y'all got the hang of that? The reciprocal of square root of 2 over 2 is just square root of 2. If you flip it and rationalize, square root of 2. So secant is going to be the same thing. And cotangent. Okay, so square root of 2. The cotangent of negative 7 pi over 4 is a 1. Okay, and that's about all these I've printed out. Oh wait, let's see. Number 24. Nice easy problem. They're not telling you the angle measurement. They're just telling you the point of intersection. It's 45 degrees, isn't it? Square root of 2 over 2. So it's the same thing we just did. 1, square root of 2, square root of 2, 1. The only difference is it didn't tell you what theta was. It just gave you the point. Here's a better one. Okay. Just to make sure you have the hang of it. They give you the point. Remember, the first number is cosine. The second number is sine. So this isn't one of the special angles. This point isn't labeled as one of the special angles on our unit circle. So right here you'd write 24 over 25. Cosine's the x value, 7 over 25. Now tangent is sine over cosine. Could y'all reduce that? Tangent. I'll do it right here. If we go sine over cosine, I'd multiply above and below by 25. You get 24 over 7. Cosecant is the reciprocal of sine, so flip this. 25 over 20. Oh, I like this. Secant is the reciprocal of cosine, so 25 over 7. Cotangent is the reciprocal of tangent, so 7 over 24. Okay. So that's it. This is using Radian Measures on the unit circle. Okay? So I'm about out of time, so I better just call it quits. So this is a sum that's 5 and 6, I believe. That's what it is this semester anyway. Working with that unit circle. So I will talk to you again soon. And I cannot overemphasize, you've got to get familiar with this unit circle. You should see it in your head. Okay? So, bye-bye. And if it's winter when you're listening to this, stay warm. It's sure cold here.